I'm Alexis.
Rajan.
Thanks for coming. Bear in mind that we just met today. We've worked together, two teams, on this thing we're going to tell you about today for about a year, but we only met for the first time today. So if we falter in our presentation, please be a little generous.
First time for
We'll take turns to speak. So we're going to talk about the adoption of Kubernetes in a large financial organization. What are the practical questions that creates? What are the challenges? How are they overcome? I will talk about the challenges. Rajan will tell you how he fixed them all. So what is the principal challenge? There's a conflict between two opposing goals. On the one hand, people are adopting Kubernetes for flexibility, to go faster, to be able to choose where to run things, what kinds of app types to run, many, many, many benefits like that. On the other hand, Fidelity is a highly regulated organization in the financial services business. It looks after people's money. It needs to know who can access its data. It needs to be very careful about that sort of thing. Security is really important, and there are all sorts of regulations that tell you, some of which were written before technology, which tell you where things have to be and who has to look after them. And there's a contrast between automation, which is something that Kubernetes does, and manual intervention, which is something that regulators do. Here are some examples. And if you're used to working outside finance, this can come as a real shock. I've seen it again and again. People who've been used to, say, doing digital apps, Silicon Valley style, many changes a day, come in and suddenly somebody's telling them, no, you can't do this. No, you can't do that. Also, quite often, someone will say, why can't we use the Elastic Container Registry? We're not allowed to use that. We have to use X. Why are we using X? We've been using it since 2003. And so on. Your favorite tools that you were used to using on that cool last project may not be there. You may not be allowed to touch them. And you may run into some interesting organizational practices that may seem a little bit old-fashioned. And this is just, unfortunately, the nature of the beast. So what was the plan? Three-step plan, as I understand it.
Sure.
Let's move to the cloud, because we'll go faster, save money, have access to other people operating services for us, instead of building data centers and running infrastructure ourselves. Let's choose Amazon first. I believe there may be others in play in the future.
That's true.
So, because we might move things around, let's choose Kubernetes, because we know we can run that on Amazon or other places too. Now, what's next? We're going to run apps. We're not going to run them directly on Kubernetes. We're going to run them on an application platform, which includes extra things like AWS services, but also the Fidelity bits, because you might have the special secret stuff that makes the apps safe to use. And when we've got that, we can start thinking about different use cases. This is what I personally like to call multi-paths, different platforms. You might have a machine learning platform for machine learning apps, or a mobile platform for mobile backend, or maybe a financial one. So that creates a problem. It's pretty easy nowadays to get a cluster up, whether you're using open source, KubeADM, or EKS, for example, GKE. But actually, you're going to run an application on a specific curated set of tools. You want to be given a machine learning stack or a finance stack, and that all needs to be manageable. Oops, sorry. So think about that before Rajan does a bit. Let's ask these questions. And you should always ask yourself these questions, no matter what you're doing with Kubernetes clustering. Do I know if my cluster is in the correct state? If I shoot Rajan's cluster and he has to restart it, can he restart it in exactly the right state that it should have been in? And can he do upgrades on all of this? Really important. If you don't know the answer to these questions, pay close attention and talk to us afterwards. And the underlying reason for this is ultimately everyone out there is doing this sequence of things in a different way. They want a machine learning stack. They need to figure out what an app is, what are the platform add-ins to have, are they going to use Kubeflow, how are they going to deploy applications, how are they going to check they're running correctly. Whoops. technology. Yes, thank you. Thank you. No, no.
Let's try this one more time.
No, it's like the slide is slide.
I think we might need some help.
We might need some help from the gentleman at the back.
Can you manually advance it?
Okay.
Can you
Don't
manually
move.
advance it?
So
Oh.
the key thing to answer those questions with all of this is you want it to be repeatable, reproducible, as they say, cattle, not pets, and even worse, no, you don't want to have a snowflake cluster. This is something that's frozen. You can't change it anymore. Don't use all these technologies. Keep it simple. So on that note, I'll hand over to Rajan, and I will be the plug assistant for this bit.
Thank you, Alexis. Before I begin, I want to thank everyone for coming here. Thank you so much. I'm Rajan. I have a lengthy name. I'm very famous for that. I'm part of an organization, awesome organization within Fidelity that is responsible for enabling cloud. And within that, I focus on the platforms aspect of it. So in the upcoming slides, what we're going to see is a few things, right? So what is this cloud-native platform? Fidelity's cloud-native platform is about. What are all the problems it solves for us? And then what is GitOps and how we use GitOps to manage the delivery of the platform? So let's begin with this. In general, right, any platform is helpful because it tries to abstract away the complexities, right? It helps user to focus on what he's supposed to do. So when you put something like that in the context of a company like Fidelity, where there is a constant push for innovation, where developers try to come up with innovative solutions all the time and then move in a very fast pace, it becomes even more valuable. The reason I say that is, let's take an example, right? So in Fidelity, if you have to take an application to production, you have to pass certain security gates, right? And in order for you to do that, you have to navigate certain complex workflows, right? Security workflows. It could be manual, it could be automated, doesn't matter. Usually what we have seen from our experience is the development teams are okay with it as long as it's one time, but that's never the case, right? So imagine you have a complex workflow that you go through, and then you want to make an update to that process, right? You have thousands of developers working, and then rolling out an update to an existing process is very, very difficult. So that is where packaging the Fidelity context in the name of a platform and then rolling it out to the users creates immense value for us. I'll take another example. This is a real example that we have. So in production, every pod needs to handle secret management in a standard way for us. So for example, any application that comes in, we sort of inject a security context within the pod. For example, it's a combination of init container and sidecar. That bootstraps the security aspect of it and then allows the application to start. So typically when the applications bootstrap, when they start, they just pick up a token which is already scoped down to what the token can do, and then it runs from there. So this is where the cloud-native platform that we have built becomes very important for us. So typically what we do here is you take a Kubernetes cluster, and then you apply certain core capabilities on top of that. So these core capabilities are delivered by like one or more add-ons. It really depends on the capability. For example, tenancy management, right? So let's say there is an end user for us. The internal clients for us are the business units. So if they come to us and say that we need like a platform in AWS, and the same platform needs to be in Azure, right? So the tenancy management should remain same. What I mean by that is how a cluster administrator slices the cluster and gives it to the tenants, the experience should remain same irrespective of the environments. So that is where the core capabilities comes into picture. So The rollout of the updates actually happen via GitOps. We have like a central repo where the entire FDK's version is maintained. We're going to see that in detail. The platform is extensible in general. So what I mean by that is, if let's say we have a business unit who actually consumes the platform, of course.
Keep going.
Yeah, so if, let's say there's a business unit that actually consumes our platform, they can sort of take the Fidelity platform and apply the business unit specific context on top of it, and then give it to the developers. So that's an added advantage. So in a nutshell, right, as of today, this is how the platform looks like. You have the infrastructure layer, right, and you have Kubernetes on top. We use managed control plane when it comes to AWS and Azure. We are actually running EKs in production. Now, the bits that you see on top of Kubernetes is the core capabilities that I was referring to. For example, tenancy management, cluster management. How do you bring the clusters? How do you create the clusters? How do you bring it to its desired state? All those sort of things. Ingress management, the integrated security model, all those things are part of this core capabilities layer. The one that you see on the top, I've actually given a star because that's a work in progress for us, but that is where we want to be. So imagine you take a Kubernetes cluster, you apply a layer on top of it. That is the core capabilities layer, and then it becomes like a general purpose platform, right? We want to take it a bit further and apply another layer on top of it saying that, hey, this is the ML layer. Now, when you do that, you get like an ML platform. So the end user experience that we want to provide is someone coming to us and say that, I need like a machine learning platform on AWS. We say, sure, you got it. And then they say that we want to move to Azure, and we need the same ML platform on Azure. When you have a model like this, we can actually make sure that the experience remains same, right? In general, Kubernetes helps you with the cloud, providing the true cloud native experience, irrespective of whether you're on AWS or Azure, right? By adding the core capability layer and the domain specific layer, we take the cloud native experience a step further for our clients, saying that not just Kubernetes, but even the Fidelity context remains same irrespective of the environment. For example, the tenancy management remains same. Before we move on to the next slide, there is one important aspect of it I want to cover. So the platform itself, if you look at it, it's composable. This is a very, very, very important aspect for us. What I mean by composable is at any point in time, right, we should be able to take a piece out of that and then replace it with something else. I don't want to oversimplify this because sometimes it's very difficult to do something like this. For example, the tenancy management piece, right? As of today, the tenancy management component that we run inside our platform, it does a lot of Fidelity specific stuff. It's fully automated. It goes from working with AD group automation, setting up tiller, and a lot of small bits. So as of today, it works for that. As of today, it works for us. But what if towards somewhere in the future, community actually takes a different approach towards multi-tenancy, and then we want to pivot, right? So that is where the composable nature of the platform is extremely important for us because that helps us to pivot at any point we want. So let's talk about GitOps. Right?
Thanks. I'm just going to go back to this just for a quick second, because I think it illustrates, to recap, so we stay on track and know where we are. You can see here the key principles. They're moving to the cloud, that's the bottom layer, but they want to choose between different options. You can see 3 options on the second layer up where it says Kubernetes. Then they have a platform. That's all the light blue stuff, including some of their own things, Fidelity bits. And then they have the individual domain-specific roles, another layer on top, which is what the end user is going to sit on. And there's the applications. So we've got a long way to get to Nirvana here. We're going to manage all of this in one simple way. One way.
Yeah.
We're going to have a declarative description of everything, including clusters, apps, all those light blue bits, and the platform profiles, and the dashboards, and the schemas, everything that we would need if we were to lose our cluster and had to reproduce it. Because the objective is to have reproducibility and automation. If we work in this way, the automated processes described in text, if you change the configuration so that you have a new application feature running on 3 nodes instead of 2, and with a dashboard change, all of that can be a single atomic change, one transaction in your config, which is then updated by Kubernetes itself in the runtime, which means that you're always converging to the correct cluster based on your description, which gets us that objective. Whoops. Pull it out completely and then put it back.
Yeah.
Try that. And I like to view this as a figure of 8, showing you in the middle what we call the immutability firewall, which is the Git repos and image repos. The human beings who are doing dev on the left-hand cycle, build, test, etc., don't touch the production things in the right-hand cycle. And the whole thing is driven by observing a difference, the diff, between the desired state, which is written down in the config, and the running state. If you can do that, then you can tell Kubernetes using tools, hey, you need to change. You need to update yourself. We can do management this way. We can do upgrades this way. We can do DR. We can do rollback. We can even take our model and project it onto different clouds and different Kubernetes instances. And so the fundamental thing we're doing here is deployment. Here's a little flowchart diagram showing you vFlux, now CNCF-Flux, interacting with Helm to do updates. And Flux is an agent that lives inside your running Kubernetes and pulls changes in from the image repos and the config repos when it's notified of a change. So if you make a change to your app, Flux will deploy that change for you by telling Kubernetes, I've seen there is a change in config. I must now get the things I need to upgrade myself. Hey, Kubernetes, now get into the correct state. So you don't need to do it from outside. You don't use manual processes. You don't use scripts. You don't use Jenkins to do deployment or any other CI tool. You don't use Spinnaker. You don't use Harness. You don't use Armory. You don't use any of those things because all of those wonderful tools as they are sit outside the cluster. And they can do other things there, very important. But inside the cluster, it upgrades itself, and it pulls the changes in instead of pushing them in from the outside. And this also lets us manage clusters, not just apps, but clusters themselves. So we can do reproducible clusters. In this case, we integrated Flux with EKS Control, which is an open source tool for managing EKS. EKS Control is now a GitOps controller for cluster management of EKS. It gives you single commands for managing EKS clusters, and it makes it possible for you to manage the EKS clusters by making changes in config. You can load add-ons this way, so you can do the whole FidX platform captured in this GitOps style through this tool, which is really cool. Finally, we can capture different groups of add-ons and call them profiles. So we had those domain-specific examples. In this slide, we're showing an app dev one, which is obviously a simple thing, but you could imagine a machine learning one, or a service mesh one, or a finance one, or a big data one, whatever you like. And it allows Fidelity themselves to control how that set of add-ons is deployed, which means they have additional compliance capability. So remember, think about what's going on inside Fidelity at this point. You've got one team which is responsible for creating the platforms, and they decide what goes in them, and other app dev teams that are responsible for using the platforms and deploying and managing the apps. So this separation has let us control what's in the platform from one team and deploy the apps on top. So here's a picture of that. You've got the profile on top of EKS, and then you've got apps deployed by Flux and Helm. OK, so Rajan, how did you use all this technology in the end?
Let's look at how the delivery of the platform is managed, right? So let's start with the versioning of the platform. So what you're actually seeing is a snapshot of the platform version. So we have a platform global repo, right? And every tag on the master branch represents a platform version for us. So typically, if what you saw was like one of the release, let's say it's 1.3.0. Typically, if you open a particular platform version, what you actually see is a collection of add-ons. And if you see that there is a version attached to each add-ons. So the add-ons themselves, the lifecycle of the add-ons is managed separately. Let's say I'm a developer responsible for the add-on. I have my own repo, CI process, testing processes, and everything. What is part of this particular repo is just a definition of a particular version of the add-on. That's it. I'm going to take an example here. This is a real example that we are working on. We're going to work in the upcoming sprints. So let's say we want to add a new capability to this platform, which is like a cost driver, right? So we want to give the ability for our platform admins to look at costs from namespace level or namespace group level and stuff like that. And for example, enabling cost quota within the system and stuff like that. So if I have to do something like that, I develop that independently, and once that is ready, I submit a PR into this repo, which is basically by doing a add-on definition. And once that is plugged into this repo, the next version, for example, 1.3.1, basically pushes that cost driver into production across the clusters. So another example would be, let's say there is a security patch, and we have like 100 clusters, for example, 1,000 nodes. If you want to change the default AMI for all the EC2 instance, it's a PR to this repo. Obviously, it's tested outside and stuff like that. But as soon as the release goes out, let's say 1.3.2 goes out, all the clusters have their EC2 instances refreshed. So we'll talk more about that. So let's move forward, right? We talked about the platform definition. Now let's look at it from a cluster owner standpoint. So let's say I have a cluster, right? So in our case, each cluster has a repo, and within that repo, there are these two files. And at any point in time, a combination of these two files within that Git repo represents the state of the cluster. The first one is what I call as a pointer file. It's a very straightforward file which says this cluster is pointing to a specific platform version. It's just a text file with that version, nothing else. The second one is the config options file. So the config options is basically what the platform exposes to the users. Let's take this forward, right? Let's say I'm a cluster admin, I have a repo, and I have this particular cluster, right? Let's say I want to upgrade from version 1 to version 2. Let's see what happens. Let's zoom in a little bit, right? So everything starts with a git push, right? There is a git push, and then I update the pointer to say that we have to move from version 1 to version 2, for example, 1.3.0 to 1.3.1, for example. So there is a PR, and that gets merged, and there is a commit, right? Now, from a user standpoint, he just watches the commit, right? And as soon as the commit turns green, then the platform is upgraded. That's the experience we provide. We use Bitbucket, and the Bitbucket status plugin helps us a lot here. So the flow is something like this. So the commit happens, and then the Jenkins pipeline gets triggered. The Jenkins pipeline actually does few processes to prepare something called a cluster state, and then it sends it to a repository manager. We have some strict security reasons why we used a repo manager. Any deployment that goes into production has to go through that repository manager if it's a binary. Basically, what Jenkins does is it takes the platform configuration file, it looks at the platform, it merges, and then there are like few things that happens to prepare the cluster state. Now, the next step here is ETS Manager, right? So we're going to talk about ETS Manager in detail, but ETS Manager picks it up, applies the state, for example, in this case, an EKS cluster, and then brings the EKS cluster into a specified state. And then we have like some automated tests that run. And basically, if that test passes, then that commit status is updated to green. So from a user experience standpoint, there was a git push, there was a PR, and then he just waits for the commit to turn green, right? Let's zoom in further. So EKS Manager, EKS Cuttle, right? EKS Cuttle is our main execution driver. If I have to explain the relationship, EKS Manager is a higher level orchestrator that actually orchestrates few things, and then EKS Cuttle is the main execution driver. On some levels, you can say it's similar to the relationship between containerd and runc on some levels. So we have this cluster state. Cluster state is there in Artifactory, our repo manager. And then EKS Manager actually watches for that, right? And in a nutshell, it actually, this is a simplified version, but this is what happens in a nutshell. So first thing is, it triggers a flow. It triggers a flow to basically manage the cluster dependencies, right? For example, if you are running an EKS cluster, you have to, you have the AWS specific dependencies, right? You have VPCs, transit gateways, transit gateway attachments, and all those things. All those things are done. And then it kicks off EKS Cuttle. EKS Cuttle basically handles two states, right? So both the control plane state as well as the node group state is handled by EK-scuttle for us. So what I mean by control plane state is, let's say, to what level of audit you need, what all components needs, logging enabled and stuff like that, right? What Kubernetes version, everything, right? And when it comes to node group state, anything that you can think of with respect to an EC2 machine configuration, auto-scaling group, anything that you can think of, that's handled by EK-scuttle. So typically what happens is, in terms of an upgrade, even an AMI refresh, we sort of create a new node group, cordon off the old one, drain the pods, and then delete the old one. So EK-scuttle is extremely efficient in this. And then the add-ons comes into picture. So ETS Manager deploys the add-ons. We'll talk about Helm operator in detail. So in general, ETS Manager waits until all the add-ons are successfully run, right? Even if one of the add-ons actually crash, the entire process is aborted, and then the cluster doesn't complete the upgrade, basically. So let's zoom in one more time. So the Addon Management framework, right? So we have some components that collectively enable this Addon Management framework, and Helm operator, Flux Helm operator is the core component in that. It's very efficient in terms of managing your add-on lifecycle. So the way we do that is, we have this platform version repo, and within that repo, you have this add-on definitions in terms of Helm release. So there's a CID. Anytime you represent an add-on in terms of Helm release, Helm operator will actually process it for you. So it has details of where to pick up the Helm chart from, the values, and everything. So in general, using FidEKs, right? So this is basically a version control collection of add-ons that delivers that core capabilities that I was talking about. I know we zoomed in like 2-3 times, but if you take a step back and look at it, the git push that the user did to go from platform version 1 to version 2, that basically triggered the entire flow. From a user standpoint, he just did a git push. So that's how powerful a git push is in our case. I think I have just 3.5 minutes. So this is a very big topic by itself, but I'm just going to take a couple of examples. Let's say a platform admin, right? He should have a standard way to slice the cluster and manage multi-tenancy. How do we do that? And from a user standpoint, let's say I'm a developer working in like multiple projects, right? At any point in time, all I have is my identity, which is the AD credentials. How can I discover the clusters dynamically using the AD credentials? So I'll tell you why that is important. So the way we manage tenancy management as of today is using custom resources. So we have something called NS Group, CRD. So irrespective of the environment you are in, whether it is AWS or Azure, this NS Group helps a cluster admin to manage the multi-tenancy. So typically what you do is you have a tenant. The tenant could be like a tech lead, a collection of developers, doesn't matter, right? So, and they might need a collection of namespaces. So we sort of group the namespaces under this namespace group and then attach an owner to it, which is the tenant. And then as soon as this custom resource is deployed into the cluster, the namespace operator which we have, it actually processes the entire flow. It's fully automated. It creates from AD groups, and it takes care of the environment-specific abstractions. For example, a cluster admin should not worry about, for example, AWS IAM or Azure IAM. Those are the implementation details, sorry. So all those things are actually taken care by this operator. So from a cluster admin standpoint, he just creates an NS group and then deploys. Because it's a CRD, it opens up a new flow, right? So this is one of the flows we have. So if I'm a cluster admin, I can actually say that the developers can actually create a PR defining what they need in terms of the namespace definitions, NS group definitions. I can say that they can actually submit a PR, and all I have to do is just approve. So if, let's say, I'm a tech lead, I have like 10 namespaces, part of a group. Let's say I want to add another namespace to it and then increase my resource quota and cost quota. I just make the changes to that NS group custom resource and then submit a pull request. So the cluster admin comes in and approves it. As soon as the approval happens, the NS group gets submitted into the cluster and then the processing happens. So we are still with Helm version 2. So we have to deal with tiller security. I'll tell you why that's here. So the way we handle that is the tenancy management automatically takes care of setting up the tiller and securely bootstrapping it. It creates a certificate, it places that certificates in a secret. But the moment you do that, the users have to sort of discover the secrets, fetch the certificates, and connect using Helm and all those things. But obviously, we don't want to give that experience to the user. We want to abstract away tiller at all, right? So that is where EKS Connect comes into picture. So typically, the client user experience is this. They don't worry about kubeconfig. They don't worry about tiller, right? Let's say I'm a developer. I'm connecting to a cluster. I want to deploy something to a cluster. So we have something called EKS Connect. You just say -- cluster, and then you plug in your AD credentials. What it does is automatically it tries to figure out, hey, this is this identity, this user, what all clusters he has access to. Then it gives the list of clusters he has access to, and then you can point to a cluster, and then it will connect. It will automatically generate kubeconfig for you. And the -- namespace is a bit more interesting. So the moment you say the namespace, right, so it automatically connects to the namespace, fetches the tiller certificates, and then sets up the Helm wiring locally. So tiller is like totally abstracted out. So I think that sort of completes the entire cycle. Before I hand over to Alexis, I just want to say that our team is here. Whatever you saw is basically part of efforts of a brilliant team. I'm very happy to represent the team here. If you'd like to join us, we have a booth. Please do visit us in E9. Thank you so much.
Thank you. So just to finish up, just got a couple of minutes left. Thank you, Rajan. Summary. We had this problem of wanting to go faster across multiple clouds using Kubernetes, but we wanted to be safe. We wanted to control how we deployed things. We wanted to choose the components of our platform. We wanted to protect them from being changed by other people. And we wanted to record what happened, in this case, using Git as an audit trail. Whoops. So we had this set of conflict of interest. Go fast, but be safe. Go fast, but be safe. And we worked with the Fidelity team using GitOps to provide that combination for the whole stack. And we got away from these snowflake clusters where everything was frozen. It could no longer be changed or reproduced or upgraded to a world of completely reproducible clusters anywhere, which gives us the additional safety of knowing that if we need to shut things down, we can, and start them up somewhere else. So to summarize, Fidelity used GitOps and Kubernetes to deploy a new cloud application platform, which is fantastic. Well done, Fidelity. Thank you very much.
Thank you. Thank you so much.